But yeah, the one that the only the phrase that the first one was bad. Yeah, that's so funny. Yeah. I didn't even know. I actually. Yeah. Oh no, I was just. Yeah. Because back then, I actually added more to it. We did. I ran out. I did. Yeah. Oh. Yeah. I actually like bike. So is that gonna put one too as a call, man?
All right, welcome back to CS160. Let's get started. Today we're going to talk about prototyping. Before we get to that, hopefully everyone has dropped off a printout of their contextual inquiry in the front of the room right now. If not, do it right now. I just wanted to quickly show you one last video that we didn't get to watch at the end of last lecture. So we ended last lecture with a discussion of the benefits and drawbacks of multi-touch interfaces. I just wanted to show you that in research, we're exploring many possible hybrids. And here's a research project from just a couple of years ago that now turned into a product. So Microsoft Research back in 2009 looked at how you might combine the benefits of multi-touch input with regular input devices such as a mouse. So what you see here is a camera-based system that detects finger touches on a piece of bent acrylic that's part of the mouse. And so now you have both pointing as well as gestures that you can perform on top of the mouse, such as zooming or flicking. Or painting with multiple fingers. So this particular prototype didn't go into production. However, as part of their research, this team actually looked at 5 or 6 different implementation technologies by which you could add multi-touch on the top of the body of a mouse. And one of them was based on a capacitive sensor, and that you can now buy as the, I believe, Microsoft Touch Mouse, it's called. And very similar technology is in the Apple multi-touch mouse. So this went really from research into something that you could buy on the shelf within 12 to 18 months. Very rapid. So any comments from you on potential advantages or also drawbacks of having multi-touch input on top of a regular mouse? Glenn.
The Magic Mouse, Apple's Magic Mouse was great initially, and I really liked it, but there were certain hand configurations if your wrist wasn't up, if you weren't like gripping it like claw, and you were more kind of sliding it around with your wrist down, I was constantly triggering like scroll actions or slide actions with the palm of my hand. So it became, so then I had to be hyper aware of my hand positioning on the mouse as opposed to just like grab and point and click.
Yeah, so what Glenn points to is sometimes called the, it's similar to what in Gaze interface is called the Midas touch, where you're suddenly firing off events even when you don't want to, and it may be hard to not provide any input. And you may actually have to adapt the style with which you use the mouse to now make sure that all of these sensors are basically recognition-based. So if you look at when we discussed how a mouse works, the switches and wheels underneath, that is all very deterministic. And here, when there are things like gesture recognition and finger tracking, there's usually more of there are more probabilities involved, and the driver software will make decisions on what's likely a gesture versus not. And once you're in that land, it actually becomes more frequent that you inadvertently trigger actions, and you may have to relearn how you use the mouse. Yes. Other comments? Who has used either the Microsoft or the Apple multi-touch mouse? Okay, so I want to hear from you.
I like it because I can do all like the Apple, like if you're on the Mac, you can like go between windows and stuff. And the only thing I don't like it is again like in order to like move my fingers to do like certain things, sometimes I have to like change it, and that's the only thing.
Yeah, so the ergonomics are tricky, but you do have an extended vocabulary of commands that you can issue. Right? Actually, what you see in here is like the multi-touch painting. That ended up not being really implemented in the products you can buy. It's much more that there are discrete gestures you can trigger with 2 or 3 fingers. So those are mainly the ones that made it into product. Okay. Just quickly plug section tomorrow. Tomorrow will be a 1-hour prototyping challenge where you will, within the span of the section, create a functioning prototype for a task that your GSI will tell you about. So this is kind of really fast-paced and fun, and it's also important for your next group assignment. So I definitely encourage you to attend this week. Programming assignment 2 has been graded. We're just finishing up the last couple of, we just have to enter a couple of comments on BSpace, so that will be released soon. Most students actually did a nice job on this assignment, and most got full points. And we assigned extra the usability of your application. So here is Claire's video that I just quickly wanted to show, because there's some nice features like a palette of tools that pops up that let you select whether you want to draw lines or rectangles or freeform. And then there's also a color wheel that's just always on screen that lets you pick black and white, which are very common colors, as well as a limited range of colors in the color wheel. One thing to think about in your interfaces is how do you represent certain concepts. So for example, here, stroke size is represented visually by having a marker of this is how big your stroke will be. And that is a more direct mapping than just showing a number that says 25 pixels. Because I may not have a good intuition for what 25 pixels is until I start drawing. Similarly, when you think about, here, let's just start this again from the beginning. When you think about how to represent color, there are many different color wheels that you may know from art class or color spaces, from applications such as Photoshop and Illustrator. And different representations are easier to reason about or not. So for example, if you give me 3 sliders, because we're dealing with RGB color, right? It may seem natural as a developer to say, here are 3 sliders for red, green, and blue. But how do you know which sliders to move in which direction, for example, to get a rich burnt orange or a dark purple? We actually don't have a very good way to reason about distances and color spaces in the components. So it's easier if you give someone a full spectrum of all the colors you can select from and have them directly select rather than having them provide numerical parameters. All right. If you found this assignment really challenging, then I suggest you meet with the GSIs to find out how you can accelerate your learning of Android, because we're gonna keep increasing the complexity from here. Which means programming assignment 3 is out today. I'm going to give you a lot of time for it. You basically have till spring break to turn it in. That is because you will simultaneously have group assignments. And I just want to make sure you have the freedom to assign the right time that works for you. So individual programming assignment 3 is you're going to create a BART application. This is Wei Wu's solution. She was a student. She's now a master's student here. She was an undergrad student in CS160 when I taught it a while ago, back when we used iOS. And so you'll do tasks like help people navigate a map, and also get real-time schedules and arrival data and prices from the BART API that BART makes available on the web. So you'll learn how to build a more complex application, and also how to read feeds from web service APIs and do useful things with them. So I think you could finish this in, well, 1 week is maybe a little short, but definitely in 2 weeks. So in the past, we've given you 2 weeks for this assignment. And just to give you the flexibility of scheduling, we're just going to extend it till spring break. It's going to be in your interest, though, to start early, because the week before spring break is also when the midterm is. And so it's your responsibility to find the right timing, how to schedule the different assignments. Also, let me just point out, because this is more complex, this is going to be roughly worth as much as programming assignment 1 and 2 combined. So it's in your interest to do a good job in this. Questions about programming assignment 3? Not yet. Details are on the wiki. I encourage you to also apply what you're going to learn today about prototyping to the design of your BART app. So make a prototype before you start coding. And we're going to go over the techniques just in a bit. All right. The other assignment that's out that is due earlier is your next group project. So within the next roughly 2 weeks, you will create a low-fidelity prototype. So first of all, we're still going to ask you to give us your current latest mission statement, as that may still be evolving for your project. And then you create a low-fidelity software prototype that demonstrates 3 of the tasks you just turned in. And prototyping software for which we have an educational license. So you'll all each group will get a login that you can use the online version of My Balsamic. And then you're going to create a video that shows how your user interface supports 3 of the tasks you identified. But you're not only going to show the interface itself, you're also going to show kind of the story around how someone would use it and what's the motivation behind using your project. All right, and what you're going to turn in is a video along with some materials over about the video. And once again, details about that are also on the wiki. Any questions about that? All right, we'll give you a couple of days to look at the assignment, get started. So for today, we'll talk about prototyping, both in theory and in practice. And we're going to go through 3 particular prototyping strategies: paper prototyping, low-fidelity software prototyping, and video prototyping. But let's start with theory. So from your reading for today, who wants to give me a working definition of what a prototype is? I can stand here and wait for a while. All right, Moshe.
Model for something that you're trying to build, something that is not a complete product.
Yeah, so a model or an incomplete product.
And the purpose behind this is to create a complete product, but presenting something that may or may not induce feedback.
Okay, so purpose, feedback. And so in the end, you want to have a complete product. And now the one question is, where along the way does a prototype fall? Is it an almost complete product? Is it something else altogether? So I'll give you a couple of definitions that practitioners, design practitioners, and researchers have come up with. So Lemon-Stolteman say it's the means by which designers organically and evolutionarily learn, discover, generate, and refine designs. This actually doesn't say anything about the final product, right? It only says it's the means by which you drive your design process forward. Bill Margaret, one of the co-founders of IDEO, said it's a representation of a design made before the final solution exists. So it's a model, a representation, and you may not even know what the final solution is yet. But it's in constructing this model that actually helps you find out what the final solution should be. Here's what a software engineer says. It's producing early working versions of future application systems and experimenting. So there's that important concept that you're not just producing them in a vacuum. You're producing them in order so you can run experiments on them. And then this is kind of a narrow definition that really focuses on, well, it's a working version. And I'm going to challenge that definition a bit and say maybe it doesn't have to be working at all, and you can still get useful data from it. Here's one of my favorite examples of a prototype. This is the bespectacled gentleman is Walter Dorwin Teague. He was one of the pioneers of industrial design. So industrial design really came into its own in the early to mid 20th century in the US. And what is he building a prototype of here? Well, he was contracted by Boeing to design the interior of one of the first commercial long-distance passenger jets. And so how do you design the right interior for an airplane? Well, it seems pretty complicated to load people on the plane, fly them around the country, just to find out whether you've gotten the right seats or not. And so what he did is he rebuilt a fuselage in a warehouse, and then just brought volunteers in and got them to spend basically an afternoon or a night sitting in this warehouse on the seats that he designed to find out whether it was going to be comfortable to sit there for 6 hours, whether there was enough space, whether the seats were too soft or too hard. And so I think it's a great example of, even for some big industrial enterprise, how you can still find answers to the questions you have by just reframing what you actually have to do and what you can leave away. He didn't need a working airplane at all. He just needed the rough dimensions of space that he had to work with. Now, the other point here I want to make while we're talking about history is that actually the user-centered design process, as we talk about it now for user interface design, bears a lot of resemblance to the industrial design process that was first explained and described in books in the 1940s and 50s. So here is a page from Henry Dreyfuss. He was another one of the industrial design pioneers. How he describes how industrial design happened in the 40s. So you start by studying the competition. You did that for your competitive analysis, right? You familiarize yourselves with the client's manufacturing facilities. Well, that for software you don't really need to do. You compile the code, it runs. It's you kind of know what an API can give you or not. So manufacturing is a little bit outside. But then we learn how the product will be used. our designers took a Singer sewing course with zigzag stitching and all, right? So this is basically the equivalent of contextual inquiry and task analysis. Then they develop a variety of idea sketches. So you sketch out your interface. You've done that for your first design assignment. And then they create models. So here, for industrial design, the form really matters. So you may make shape models. For user interface design, behavior matters. So you make interactive prototypes. Those prototypes may be informed by theory. So Henry Dreyfuss published a whole book on basically percentiles of measures of how long human arms are in the 5th percentile, on average in the 95th percentile, for children, for women, for men, how far people can move their head, what their field of vision is. And that is basically the equivalent of the model human processor and other models we now use in user interface design. And then they create pilot models, which then eventually turn into fully functioning prototypes that then go into production. So abstractly, this design process comes down to something like this. You start by understanding and observing, and then you go into the cycle of visualizing, prototyping, evaluating, until you run out of time or money. So here's prototyping for today. And at the core is what we saw in lecture 1. All right, so let's really focus in on prototyping. I'll argue that there are at least 3 different benefits to prototyping. One is we know more than we can tell. So there are types of knowledge that are hard for us to write about or reason about abstractly, but they're easy to perform. The second one is that there may actually just be a performance benefit. It may be faster to create a prototype than to think about it hard. And the third one is the value of surprise. So when you create a concrete representation of your design, you often get these aha moments of, oh, I haven't thought about this corner case. I haven't actually resolved this detail, or this is not going to work how I thought it would be. And those are usually really valuable opportunities for design. So we know more than we can tell. Well, think about other skill tasks like playing basketball or architectural drafting or crafts or playing musical instruments. Who in the room is a musician, plays an instrument at some level of skill? Okay, that's the majority. How many people play, let's say, a wind instrument? Okay, describe to me how you play wind instrument.
Me?
Sure.
You blow air against a reed and use your fingers to change the airflow and dynamics through the instrument.
Yep, that is, some model of what happens when you play a wind instrument. It didn't capture at all how you learn to be a virtuoso player. And these are learned skills, like riding a bicycle, right? Tell me how you ride a bicycle. Well, you get on and then you somehow balance. They're just skills that we acquire over time, and they're kind of bound up in the performance of the skill. And we can't really describe what that skill is, and we can't teach it by saying it to anyone else. You just have to perform it. And a lot of design knowledge is the same, but it's tacit knowledge that you gain through the practice of design. And so you can only express that knowledge by doing design rather than thinking about design. The other argument is that taking physical actions may actually be faster, may outperform thinking about a problem. And my favorite example comes from a study of the game of Tetris. So Kirsch and Maglio studied Tetris players, and they studied novice players and expert players. and they found a curious result. You may think that expert players know exactly what to do the minimum number of moves to drop a piece in the right spot. And that's actually not what they found. Expert players would rotate and move pieces more often than necessary. And why is that? Well, the hypothesis is that it's actually harder to do a mental rotation and a mental translation than to just push the button and see the visual pattern that results and then make a visual pattern match, whether that is right or not. So doing the physical action and then getting visual feedback of what just happened in the world is faster than thinking about how you should rotate the piece and how you should position it. And similar results have been found in studies of the game of Scrabble. So it helps you form, moving the tiles around with your fingers helps you form words rather than just looking at the tiles and thinking about them. And so there's a bunch of evidence where taking physical action in the world can help our cognitive processes. All right, well, what's the purpose of prototyping? So what questions do prototypes answer, and when should we make them? This came from the reading. This is a rough taxonomy of different functions of prototypes, so let's just step through them. The first one is to understand existing experience. So this is what you've just done in contextual inquiry, right? You wanted to understand the existing experience. But you can also use prototypes for that purpose. So you can put yourself into someone else's shoes, quite literally. So for example, here's a prototype to find out what it feels like to use a cell phone as a person who has reduced mobility in their hands, maybe because of arthritis or other problems. So you put a thick glove on, that now limits your own dexterity, which lets you experience firsthand whether it's easy or hard to use that phone as a person who has less mobility and less accuracy in their hands than you. So designers have called these experience prototypes. Here's another one. Here's, understand the experience of dining cars on trains. You just give someone a card that says, pretend you're hungry, go try to find something to eat. So now you have a role to play and something to act out to experience yourself what it's like to find the dining car, whether it's easy or not. All right. The majority of the ways in which you will use prototypes in this class, though, is in these other two categories. The first one, which I called inquiring actions. So they are actions that give you more information about your design itself. And so here's a diagram that comes from the director of prototyping at IDEO. And there are many different models. I just thought this one was particularly nice. And he says, well, in our project, we really find that there are 3 different stages, and prototypes serve different functions in those stages. So early on, when we're dealing with a lot of ideas, we build prototypes to inspire us, to explore the space of what's possible. In the mid-game, we have an idea of what the application is, and maybe a first idea of the design. Now the design needs to be evolved. Right? Is technique A for selecting items from a list of 500 better than technique B? So it's more focused, and oftentimes this takes the form of running A/B tests. You implement 2 minimal prototypes that embody your options, and then see which one performs better. And then late in the game, oftentimes design actually ends up with producing a specification that you then give to software engineers or to manufacturing engineers. And so in the end, oftentimes, you make very specific experiments to validate whether your specifications are indeed correct and feasible. So we won't quite get here in this course, but certainly these first 2 stages should be very relevant to you. So let me show you a couple of examples of prototypes. Here's a very early prototype for a digital camera made by IDEO for Kodak. This was when people were still using 35mm and APS film. And so it was simply a new idea that you could digitally store your images and show them right away. So the design question was, well, what's the user interface for now managing your images on the back of a camera? So IDEO built this prototype, which is not to scale. Right? That would be a huge camera. Moreover, you'd have to carry a power PC along with you. So there's this thick umbilical cord. Actually, the application, all the graphics are computed on a desktop and then just piped to the screen. But what's important is, the right I/O affordances are here. So they said, well, we can have a small number of buttons and a wheel and a screen in the middle. So let's have those, so you can have the experience of what it would be like to review images, maybe delete them, edit them. Without actually, for this prototype, there was no need to actually be able to shoot images with this camera. So you pick what's within scope and what's out of scope, and then you build the prototype in the most efficient possible way to only address the questions that are within scope. Here's another example, early prototypes for the Microsoft mouse. We just talked about the multi-touch mouse where ergonomics really matter. So the industrial designer here for the original Microsoft mouse made about 80 different foam models to find out which shape looked visually appealing and felt right. And because shaping a block of foam is much faster and cheaper than injection molding a piece of plastic, right? They could afford to make 80 and find the right one out of that set of 80. This one's from Handspring, kind of similar to the digital camera example. This was how they tested new applications for the Trio. The applications, once again, ran on a laptop, but then that was tethered to production hardware, so you could get the input from the PDA, but the output was shown on the laptop screen. All right. Last category of prototype purposes is to communicate. So here, you're trying to uncover knowledge for your design team. Here, you're trying to guide discussion. And that happens in two ways. One is if you have multiple different disciplines on your team. For example, a mechanical engineer, an electrical engineer, and a UI designer. We tend to speak different languages in different disciplines. And when I say design, that probably means something entirely different to a mechanical engineer or an electrical engineer. And nothing is quite as effective to get people on the same page as just to put something in the middle of the table and point to it and say, it'll look and behave like this. And the other reason is to persuade people. So a lot of design happens in consulting, and you may want to convince people that they should write you the next check, that you've made progress, right? And so that is very different in purpose from uncovering knowledge for the design team. So let me give you one example. This is Leza Reichelt from the UK. She was the lead designer on the public redesign of Drupal.org, the website for the content management system. And so one of the goals here was to get the community on board with the redesign, something that failed rather dramatically at the end of last year with the new UC logo. And so her process was to create these wireframes, put them up, ask for public feedback for a period of a week or two, then say, OK, that's now closed. Let me do a redesign based on your feedback. Here's the next iteration. Here's what we discussed before. What about this? And then through many stages, kind of increased the fidelity with stakeholder input along the way, so that in the end, you said, we arrived at this through this long process where all of you had a role to play. And it kept going. All right. So those are the purposes of prototyping. Let's switch gears and talk about just the nuts and bolts of different techniques for creating prototypes. First one is paper prototyping, where you will not touch a computer at all. So the materials are office supplies, Post-it notes, markers, tape, scissors. And then you basically draw your interface out. So you did some of that for your first individual design assignment. But over time, people have evolved various rules of thumbs, heuristics of how to effectively create paper prototypes. So something you will, for example, see is modularity, that there's a screen, but then individual menus are created on different pieces of paper. So you can swap pieces of the user interface in and out. So for example, you may have little paper tabs on icons that you can have appear or disappear. Or you can make frames for sliding graphics in and out, so it becomes clear that you're simulating this mobile device. And to give you an overview of this process, I'm going to show you a video from the Nielsen-Norman group. So we already heard about both of them. So when did you hear about Nielsen? Right, he came up. Okay, so for conducting these tests, right, you need at the minimum 2 people, because the person who plays the computer, all of their cycles are going to be consumed by just keeping track of all these pieces of paper. And you want someone else to take notes. In addition, it's good if you have a facilitator who can explain the task, put your participant at ease, and maybe a greeter if you're bringing in multiple people, one after the other. And so the protocol is roughly preparation, the actual test, and debriefing. So for the preparation, you may put people at ease, explain how their video is or is not going to be used, whether it's going to be confidential or whether you're going to share it with everyone else in CS160. And then the test, it's often good to do a quick sample where you demonstrate how interacting with a paper prototype will work, especially if your participants are not familiar with that. And then you'll give tasks to the user, try to do X in this application. And then as a facilitator, you kind of want to keep prodding people to follow what's called a think aloud protocol. So you want them to speak what they are thinking and what their strategies are for accomplishing the task, because that's the only additional data you'll have in addition to their action to understand what they meant. And so if they're just silent and clicking on things and you watch that video later on, it's entirely non-obvious why they took certain actions. Were they confused or not? Were they just trying to explore what the interface offered? So it's really important to get your participants to speak aloud during the test. As an observer, you want to be as impartial as possible. And that is hard. So you don't want to tell people, oh, no, don't go there. You want people to fail and realize that you really have a problem in your interface, right? And that is often hard. You have to restrain yourself, especially if you run a number of tests and every person keeps running into the same problem. And so you really only want to intervene if people are really stuck for a long time to get them back onto a useful path. And then in the debrief, it's often good to have a questionnaire, especially written, so something like a Google form or a SurveyMonkey survey is really useful because you end up with some structured way of recording responses from multiple people. and then ask specific questions for where you notice that people got stuck. All right. How do you prepare for a test? Well, you've heard this many times now, right? Don't just bring anyone in. Make them target users. Ideally, they shouldn't be your friends or family. Make them realistic users of the final application. Prepare scenarios. These are scenarios for the tasks you've now written up in your homework, and then make the prototype support those tasks and ask questions about those tasks. It'll be too tedious to kind of map out the entire application, and oftentimes not necessary. So think about what you actually have questions about. And then being the computer actually takes a bit of practice, so you want to do a couple of trial runs. As the person who plays the computer, it may be valuable to actually map out the entire interaction flow. So which elements can lead you from where to where, and then use that as a reference, but don't show them to the participant. Right? Because the participant only sees the system image and nothing else. Okay, and then the important part is you want to record, the observer should record critical incidents that happen. So anything that's unusual, mostly these are problems, but you may also want to record things that were really successful so that you have a record that this is a feature we should keep in our design. And then with the results from that task, well, you update your task analysis and rethink the design, just as with heuristic evaluation. You'd create some priority list of what to change. Focus on the severe ones, and of course, anything that's easy and quick, fix those too. Now, this think aloud protocol is really useful to understand what's going on in your participant's mind, but it's not always accurate. So one thing it impacts is timing. If people have to tell you what they're doing, right, they're going to take time away from the task, take longer. And the other problem is whenever you give people a question in a testing situation, they're going to tell you something. And whether that is actually the underlying motivation or not may be hard to discern. So take those with a grain of salt. All right, so that's prototyping in paper. We used to run this course with a lot of paper prototyping. In the meantime, the software prototyping tools have also gotten sufficiently flexible and fast that now what you're going to do for your class project is you're going to use low-fidelity software prototyping tools. So let's talk for a moment about fidelity. So fidelity refers to the level of detail and resolution in your design. So high-fidelity prototypes look and behave like the final product, where low-fidelity ones are, there's ambiguity, there are details missing, there's room for interpretation. So paper prototypes are definitely on the low-fidelity end. But what about software? Now we can actually be anywhere on the spectrum. So why not just do everything in high fidelity, jump straight into, let's say, Photoshop?
It takes a lot of time.
Yes, it takes a lot of time. So the reason we're using prototypes to get feedback on our design in the first place is that it takes a lot of time to produce the final app, right? And we want to get feedback early and quickly and frequently. And so just like doing a final implementation in code takes a lot of time, also doing pixel-perfect design takes a lot of time as well. But there are other reasons. Yes?
And also, I think the user who's testing the prototype, if you have it, like, say, built in Photoshop, they might feel reluctant to, ask for changes.
Okay, so the point here was people may be reluctant to ask for changes when you show them a very polished Photoshop design. This is, yeah, so there's definitely a truth to that. What happens is the type of prototype, the fidelity that you produce, affects the type of feedback you get in return. So if you show someone that something that looks like it's a polished application, people may actually assume that you've already done the implementation. And then it may be hard to reset the expectations that, no, there's actually nothing that works yet. We just move pixels around. And the other problem is that showing high fidelity designs tend to guide people to focus on minute details in their comments. So for example, that font looks a little bit too bold, or this color scheme clashes a bit. And at some point you want feedback on the visual aesthetics. But if you're just trying to figure out whether you want the screen in your design at all or not, if it's about the structure, then this is the wrong kind of feedback. Right? So if you really want high-level feedback, show high-level ideas. And if you want really detailed feedback, then you need really detailed designs. The other process at work is sunk cost reasoning. Because it may take you a while to produce a really polished Photoshop mockup, you're now much more invested in keeping that idea around, because it took you like half a week to make it. Whereas if you just scribble something down on a piece of paper or use rapid software tools, and you only invested half an hour, then it doesn't matter if it turns out to be a bad idea and you want to go into a different direction. All right, so for lo-fi prototyping in software, there's a group of tools that are called informal design tools. And it was actually a Berkeley professor, James Landay. He used to lead the HCI group here about 10 years ago. He's now at the University of Washington, who really did foundational research in informal design tools. So the goal is to be as rapid and as flexible as paper prototyping, but to add the benefits of digital media, such as undo, copy, and paste, making it easy to save, state, resize, etc. Now, it may also be, what I've also seen is people doing hybrids, so using software tools to make quick mock-ups and then still printing them out for paper prototyping. So there's a whole spectrum, so I want to make you aware of that. And so the example I'm going to show you is balsamic mockups. Who in the room has seen or used balsamic before? So that's about 10 people or so. That's maybe new for most of you. And here's an example. So it looks kind of like slideware, except so like PowerPoint or Keynote, but it's optimized for producing user interfaces. So you can drag and drop elements to arrange into a UI, and then there's also this really rapid editing built in where here's a complicated menu, and there's some text syntax behind it. So as soon as you learn the ins and outs of that syntax, you don't have to draw boxes for each menu item separately. You just enter a couple of lines of text and have the application interpret that as a list. And so that's one of the tricks that makes it really rapid. And notice everything here has that same rough quality that paper prototypes have as well. All right. So once again, in section tomorrow, come to section, and you'll use balsamic mockups to create one of those software prototypes for an app in an hour. Now, on the higher fidelity end, you often create visual mockups that really look more like the final application. And those may or may not be interactive, right? Those are kind of two orthogonal dimensions. What's the visual look, and how much does it behave like the final function, the final interface? And it turns out to be hard. The more you try to combine the two, the more you're inching towards just implementing the whole thing anyways. And so it's hard to make something that looks polished, has polished behavior, and is fast. Tools that are often used are Flash Catalyst or Flash. That's kind of ramping down in usage. And then a lot of people also use Keynote and PowerPoint, but in very specific ways. Namely, there are libraries you can buy online where basically people have, using the drawing tools available in Keynote and Photoshop, have recreated all of the widgets that usually ship with iOS or with Android or that you commonly find in web applications. And so then you rearrange all of these widgets, which are really just graphics, onto slides, and then you link different slides to each other. And each slide there shows one key screen. Now, remember I told you different purposes of prototyping. There's like inquiring actions and communication. So that's important when you, that distinction is important when you create these types of visual prototypes as well. So I think of it as telling versus testing. So if you want to tell someone how a touchscreen interaction works, it's important to show what the user is doing, right? So it's probably in your interest to like have some visual icons on screen, some visual representation that says, now a user is tapping here, or they're sliding somewhere else. Because with a standard desktop interface, there's always the cursor. Now, with a touch interface, you need to have the equivalent of the cursor to communicate what the user is doing, because it's not in the screen itself. So you want to add that to your prototype. When you create these narratives, you're in complete control. Right? You completely control the whole story of task and the screens that somebody sees. And the contrast to that is, if you want to test your design, you're actually creating some interactive artifact. So in slideware, this is usually done by highlighting elements on screen and linking them, basically creating hyperlinks. It says, if you click on this, go to slide 7. If you click on this other element, go to slide 5. And so you have your screens, and you basically create, all the different transitions in the state diagram, what leads you from where to where. And you have to author that, and then you just give it to someone and say, here, take test drive, much like the Wizard of Oz testing, except now all the logic is actually embodied in your slide deck. Turns out this works well for simple logic, but it quickly gets complicated. And these tools are not really meant to be used in that way, so it's easy to get bogged down after a while. And that's when you know you should stop, because you've reached the limit of this particular prototyping technique. All right. I think I already said that. What about high fidelity and fully interactive prototypes? So high fidelity visually and in behavior. It takes a lot of effort to build. So it may be less effort to do something in HTML and CSS and JavaScript than to do it in the Android SDK. But still, you're going to invest on the order of days, and you got to ask, how much payback are you actually getting for that investment? And so a couple of other tools that get used are, just JavaScript libraries that are optimized for touch interactions on phones, like JQ Touch, or Apple's Dash Code, which was really originally a tool designed to create these widgets on your screen, but can also be used to make interactive phone prototypes. All right, last topic for today, video prototyping. So in video prototypes, once again, you control the entire story, which means you don't actually have to implement any functionality. You just have to create the look and then have some editing chops to sequence shots so they appear like there's a working piece of software. Sometimes these are narrated, sometimes they aren't. For your assignment, you'll definitely have to create a narrated video prototype so you can explain to others what they're seeing on the screen. And that is actually a really helpful feature that prevents you from having to do extra work visually explaining in your interface how things work, because you can just not show an animation and say in the narration, and then when you click this button, the screen will slide to the right and you will see this screen. Right? There's this suspension of disbelief in any animation, and having a narrator helps you have less of a burden in your own visual design and make it easier on you and faster. We talked a little bit about storyboards early on, and really storyboards become really useful when you're making video prototypes. And so if you have a good storyboard first, and then let that drive what you shoot and don't shoot, and don't capture any extraneous materials, you should be able to create a video prototype in a couple of hours. So how do you create a video prototype? Once again, you take your ideas and inspirations from your brainstorm and your contextual inquiry, from your scenarios, and then for each task scenario, develop a storyboard, and then kind of each frame in your storyboard, shoot one video clip for that. And the video clips could either be live action, or they could be focusing on the screen and showing screen capture of using balsamic mockups, or showing you moving pieces of paper around to simulate how the UI would behave. Let me just show you some examples of video prototypes. So here is a more professional one. Notice the use of annotations. Those are quick and easy to add, but they help explain things that otherwise may be ambiguous. All right, and now here comes the interaction. So what you see here is a kind of a common pattern, right? There's some setup of what's the setting, what's the context, and then switching to here's the interaction I do on the device, or here there were also barcodes involved, and then the end result, person walks away with the right bottle of wine. What did they actually have to implement to shoot this video? I saw about 4 different screens. They could have been 4 static images, or could have been HTML mockups. And then there was this smart system that turned on the right lights, right? Did you have to build that smart system? Could have been someone sitting just out of frame turning the right switch on and off with standard lamps behind the wine rack, right? You don't know, but it creates a compelling narrative of how this future product would work before you've ever built anything. So then I wanted to show you a couple of prototypes from CS160 that students have done in this class. Let's start with roll call.
This is Mr. Dugan, a middle school math teacher. While he means well, Mr. Dugan can never seem to catch a break. His numerous students and classes cause him far too much frustration. He is looking for a simple way to track his students' attendance and behavior. all while in class.
I went to class, I have to take attendance, the students are going crazy, what am I going to do?
This is a job for work.
I have to solve all my problems. Now I can take attendance and record behavior with you.
Well, Mr. Dugan, your roster isn't in the iPhone application. Don't worry, I'll just sync it.
Mr. Dugan simply clicks the Sync tab, selects his class, and taps into the file. Roll call takes the URL and does the rest.
Okay, let's take attendance. Mark Del Negro, Julian is absent.
To take attendance, Mr. Dugan simply taps the names of each student who is not here.
Who are you?
I'm Jordan, Dean.
Oh, a new student. Let me add you into my class.
To add a new student, Mr. Dugan edits his geometry class and clicks Add Students. Since Jordan is new, Mr. Dugan clicks the plus button to create Jordan's profile. Jordan is then automatically added to the class.
You're doing a great job. I'm going to give you a point.
A student's daily point value is accessed via the blue arrow.
Hey, you! Never bacon in class. You're losing a point.
Daily notes can also be accessed in this same menu.
Class dismissed.
So you get the back and forth of showing context and motivation and then focusing in on the app. And in this case, it was all stop motion, like a camera on a tripod, pieces of paper, and then shooting many different still images to create the illusion of animation. I'll show you one other one. So here, I'm just going to go into the middle of it. This is an application for managing communication between renters and landlords about apartment problems.
Number.
All right, not the right spot here.
Oh, come on. Wait, the line is broken? What is she?
The application now takes him straight to the tenant page. Roshi already has an account, so he fills in his username, password, and logs in. He needs to report a problem. His information is already in the system, so he simply fills in the quick problem description, rates the severity of it, then takes a photo.
I guess that should do it.
The manager is currently playing Minesweeper in his living room.
Oh man, broken lights? That's hardly a problem. Better just lower the priority and come back to it later.
The manager can manually adjust the priority as well, like a to-do list of sorts. Later today, he will go and fix Billy's problem.
All right, just to wrap up here, so some tips and tricks for creating your own videos. Have a title, and start with this establishing shot. So don't jump into the UI. Give us a reason why we care about the UI, and then kind of go back and forth between detailed and these mid-range shots that continue to keep this illusion alive that there's this continuous task that goes between, you know, what happens in the real world and what happens on your device. Give yourself some credit at the end. You can do stop motion, where you just take a camera. If you're interested in that, we can show you some tools, and you just basically take 10 frames a second, and that gives you a way to simulate motion if you don't actually want to implement any animation yourself. All right. Now for the wrap up of the whole lecture. So the advantages of low fidelity prototyping, it's easy and fast. You don't need a lot of specialized skills here and not a lot of time. That gives you the opportunity to test multiple alternatives and iterate quickly. And so a number of iterations are positively correlated with overall quality of your design outcome in the end. If you're doing paper prototyping, you can also just adapt the interface in mid-test. Right? If a user tries to do something that you haven't designed yet, just draw it on the spot and say, well, how about this new screen? And then keep a record of it. Now you have already an idea for a redesign. And so this kind of Wizard of Oz typing testing, where you have someone simulate being a computer, that's really useful for things that are really hard for computers but easy for people. So speech and handwriting recognition. Except you got to be aware of the fact that your final implementation may not be as good as the human eye or ear, and that your implementation may not be error-free, where it's very easy to have an error-free test. Some of the drawbacks of low-fidelity prototyping. You may have to kind of start from scratch, draw something, or make a new mock-up multiple times. That can be slow, but changing code is even slower. And the other thing is there's no way to now hand off this design in an easy way to reuse it in code. So really, you're only producing a spec that you then have to start to re-implement from scratch. So that's a little bit more effort. People have tried to build prototyping tools that then directly feed into the development process, and that actually doesn't turn out to work very well because all of the cruft and the ugly workarounds that you come up with during the prototyping stage, you don't really want to have those around when it comes time to write code. And then some things are just harder to mock up, like any continuous direct manipulation, multi-touch interactions that continuously track your fingers. Those tend to be time-intensive to do in paper prototyping and just not supported in tools like Balsamiq. So then it comes to video editing. How clever can you be with video editing tools? And it's very easy to sink an entire day into editing like 10 seconds of footage. So that's just a warning. Stick with, for this assignment, I would use the simplest video editor you can find. So don't use Premiere or Final Cut Pro, just to never get tempted to spend the next days just editing smaller and smaller details of your video prototype. Once again, it's a question of fidelity, right? You don't need that fidelity yet at this point in your project. All right, and the summary of the summary. Use these rapid prototyping tools to design and test before you ever cut a single line of code. It's really the best. This is right now the time for really rapid evolution and elimination of problems before you get bogged down. Paper and ink, paper prototyping was really the standard tool for a while, but the software tools are up to par, I think, these days. So that's what we're going to use in CS160. Next time, we're going to start talking about the nuts and bolts of engineering robust, high-performing user interfaces. So we're going to talk about event architectures. And as usual, there's a reading response due before class. All right, see you on Monday or in office hours right now.